Hello everyone, myself Salaam from Department of Pharmaceutical Chemistry. Welcome to the webinar of POC2, Pharmaceutical Organic Chemistry 2, in which we will be discussing about aromatic acids. Okay, what are these aromatic acids? So you might be knowing about benzene. So benzene, when it will be having carboxylic moiety on it, we call it as aromatic acid. So the first simple aromatic acid is benzoic acid. Benzoic acid is our first aromatic acid, which it will be having COH group, carboxylic group on the para position. Another important example for the carboxylic acid is 2-hydroxybenzoic acid, which is most commonly called as salicylic acid. It is a natural product which was obtained from the plant, and later it has been used for various synthesis of various pharmaceutical products. And next is another important carboxylic acid includes 2-amino-benzoic acid, which is also called as anthranylic acid. Another one, when you are having both the carboxylic group attached side by side, we call it as phthalic acid. Phthalic acid is also an important precursor for various compounds of the medicines. And next example is benzoic acid, when it is having CH3 moiety, when it is having the methyl moiety on it, on the para position, carboxylic acid, and the next to it, it is having the methyl. We call it as 2-methyl benzoic acid, which is also called as tolic acid from the name toluene. Another important benzoic acid is 3-nitro-benzoic acid. So these are the aromatic acids. Simply benzene having carboxylic acid are aromatic acids. It could be of having functional moieties, different functional moieties onto it, either hydroxyl, methyl, amine, or nitro. Coming to the various properties of aromatic acids. So here, if we go towards the acidity of aromatic acids, acidity of aromatic acid by the name itself, they are having the acidic nature because of the presence of the carboxylic group, and acids are those substances which have ability to donate the proton based on Bronsted-Doric theory. Acids are those substances that donate the proton. So the pi electron plays an important role. Pi electrons are nothing but the double bonded electrons which are present in the benzene that have played an important role for enhancing the acidity of aromatic acid. So the negative charge on the carboxylate, that COH ion which is there, it will be getting stabilized by this presence of this unsaturation, that alternate single bond, double bond. So here you can see that this carboxylate ion having the negative charge on this oxygen initially, and it can delocalize itself. The positions can be changed, and then it can be giving the negative charge on the other oxygen. So this makes carboxylic acids much more stronger or better acids than their aliphatic counterparts. Aromatic acids are much more acidic than their aliphatic counterparts, like if you go towards acetic acid and other acids. So these are much more having ability of acidity when compared to their aliphatic compounds. So here let us see factors affecting on the acidity of benzoic acid. So we got to know that benzoic acid is being acid, has the ability to donate the proton. And now, what are the factors, presence of which group affects its acidity? So here, benzoic acid, when it is being having nitro group onto it, like NO2, if it is there, it will be more acidic. So electron withdrawing group, nitro group, NO2 group is an example of electron withdrawing group. So whenever there is an electron withdrawing group on benzoic acid, it increases its acidity. So that is like what happened. It can easily release the proton. How the acidity increase? Based on the ease of release of proton, H plus ion, So when there is a presence of electron withdrawing group, that ease becomes much more easier for the benzoic acid to relieve, carboxylic acid to relieve the hydrogen. So it becomes more acidic. So electron deficient atom stabilizes the anion, and ortho position by electrophilic group increases acidity due to the steric effect. Electron withdrawing group increases resonance structure. How it is increasing? The number of resonance structures with an electron withdrawing group, it will be increases, and hence increases the acidity. So here you can see totally it is forming four such resonance structures, and these resonance structures are responsible for having more stable anion, carbanion of the benzene ring, having more stable negative charge getting stabilized, due to which it easily gives out its proton and becoming more acidic. Similarly, electron donating group, what happens? Electron donating group, initially itself that carboxylate ion is negative, and when you are increasing or putting an electron donating group, what happens? Its electron density gets increases, due to which acidity decreases. Because if the electron density increases, proton will be holding up that position. It will be holding that more togetherly to that benzene ring. It won't leave it because benzene ring is becoming more electronegative. So it is difficult for removal of that proton. So that is why acidity gets decreases if you are adding up electron donating group, because proton won't leave the benzene ring easily. The carboxylate proton which is there, it won't going to leave the benzene ring easily because its density has been increased. Proton gets attached to it. So electron receiving group reduces the resonance structures. It won't give much resonance structures, due to which what happened? The acidity of the benzoic acid gets decreases. So here, simplified, if you say, if you're having an electron withdrawing group, what they do, withdraws the electron from the benzene and lowers the electron density, and potential decreases the potential energy of the benzene ring, increases ionization and decreases the enthalpy, hydrogen, heat of hydrogenation, due to which what happened, the equilibrium shifts to the right side, and it will be giving out the proton much faster, and electron withdrawing group will be increasing the acidity. Whereas if you are having an electron donating group, like para-amino benzoic acid, amine is an electron donating group. So what happened? They will be increasing the density of electron. So electron density increases and decreases the ionization part, because hydrogen doesn't easily remove easily now. So what happened? Heat of hydrogenation increases. You need to provide more energy for that benzoic acid related derivative to give out the proton. So it becomes less acidic, and electron donating group thus decreases the acidity of benzoic acid. So bicarboxylic acids is meta-directed. You know that there are different directing groups, ortho-para-director, meta-directing group. So carboxylate ion, that COH, is an example of meta-director. So ortho and para position in benzoic acid carries positive charge when we see, because of the delocalization of the hydrogens of the double bond pi electrons. When they get delocalized, what they do is they would be adding up the positive charge. So this electron is getting delocalized here, and then after it comes here, the bond gives out the charge. So here what happens? These charges will get accounted or accumulated at either para position or on the ortho position. So due to the presence of positive charge on the ortho and para position, so these positions now cannot occupy by the others. So what happened? What is the left out? So it doesn't allow the electrophilic position. Electrophiles cannot attack the positive positions. Electrophiles are electron loving. means they would be attacking on the negative positions because electrophile itself is a positively charged. You know that, like repels. So as it is giving out the positive charge on ortho and para positions which are available, so the coming electrophile won't be attacking on that because like repel each other. So left out position is which one? Meta position. So that is why, because these are uh, opposing the attack of electrophile, left out positions is meta. So that is why carboxylic acid allows the meta position to get electrophile. So thus carboxylic acid directs all the electrophile to the meta position. 5-carboxylic acid act as a deactivating group. We got to know that carboxylic acid is a deactivating group. Why? Because it is not activating the ring towards electrophilic substitution. It is blocking the 3 positions of the benzene ring, and that is why it is said to be deactivating group. Undergoes electrophilic substitution more slowly than benzene, and that is why withdraws electron from the ring, which makes it more unstable. So when we compare the reactivity of benzene with that of benzoic acid, it is much lesser because benzoic acid presence makes the benzene ring little bit unstable and don't allow the electrophilic substitution much faster. It makes it slow in the reaction rate, decreases the reaction rate of the benzene ring. So that is why it is regarded as an electron deactivating group. So decrease electron density, make it less attractive for the incoming electrophile. Hence, electrophilic substitution is slow when there is a benzoic acid or carboxylic acid group present onto it, and it will be directing the coming either nitro group or any other group towards the meta position. So oxidation of benzyl chloride. So reaction of phenyl magnesium bromide with carbon dioxide or basic hydrolysis of benzo trichloride, or by the acid hydrolysis of benzonitrile or hydrolysis of phenyl benzoate. So these are the various methods of preparation of benzoic acid. So now let us first see oxidation of benzyl chloride. So here, benzyl chloride is nothing but when benzyl group or benzyl molecule. What is benzyl molecule? Benzene with a CH2 is benzyl molecule. So when benzyl molecule having a chloride onto it, chlorine onto it, we call it as benzyl chloride. So benzyl chloride, when it gets oxidized in presence of water, so what it takes, it needs alcohol, benzyl alcohol. This benzyl alcohol on reaction with potassium permanganate, it has a very strong oxidizing agent. So this potassium permanganate on reaction with benzyl alcohol gives us the benzoic acid. We go towards the mechanism here. So first of all, the chloride moiety removes from the benzyl chloride, and which allows the hydroxyl to get attached onto it and gives us the benzyl alcohol. This benzyl alcohol gets oxidized with KMnO4 and removes H2 and takes up some oxygen into it, forming the benzoic acid. Coming to the next method of preparation of benzoic acid is from reaction of phenyl magnesium bromide with carbon dioxide. So this phenyl magnesium bromide, what is this phenyl magnesium bromide? It is an aromatic Grignard reagent. Okay, so Grignard reagent, alkyl magnesium halide. So this phenyl magnesium bromide we take, and when we are going to react with carbon dioxide, so we are doing the carboxylation and forming a magnesium benzoate bromide moiety, which on reaction with water gives us benzoic acid. Okay, so this is one of the method of preparation by the Grignard reagent. We are using phenyl magnesium bromide and carboxylating that carbon dioxide to give an magnesium bromide, benzoic bromide salt, which on hydrolysis gives us the benzoic acid. So phenyl magnesium bromide, the carboxylate ion, will be taking up the water molecule and reacting up with the benzoic, benzoate salt. This benzoate salt in presence of water, it goes hydrolysis breakage of that MgBr moiety to give us the benzoic acid. So next is benzonitrile. Using benzonitrile or cyanobenzene, we can tell. Okay, with benzene when it is having CN onto it or cyanide moiety, which is also regarded as nitrile. So this benzonitrile, when it is getting hydrolyzed with water, it will be giving us benzoic acid. So here what happens, the water, OH minus ion of the water will be attacking the carbon and giving us an intermediate, which further reacts with water to give us the final benzoic acid, which replaces that NH nitrogen with the oxygen of the water, and that will be giving us the benzoic acid. So initially, the hydroxyl ion and proton are responsible for getting an addition reaction happens there, and then after the addition, then will be the cleavage hydrolysis happens to give us the benzoic acid. Another is from the toluene, okay, basic hydrolysis of toluene. Toluene is nothing but benzene. When it is having CS3 onto it, we call it as toluene. So this toluene, when it is being reacted with chloride, it removes the hydrochloride and it will be giving benzene trichloro. And this trichloro toluene, when it is being reacted with sodium hydroxide or basic hydrolysis, we call it as, when the breakage of the water molecule or molecules in presence of a strong base, we call it as basic hydrolysis, gives us the salt of sodium benzoate. This sodium benzoate further by adding few drops of acid gives us our benzoic acid. So initially what is happening here, after getting that trichlorotoluene, this sodium hydroxide hydroxyl ion will be attaching onto it, giving hydroxyl dichloride toluene, which on water, in presence of water, removes the two hydrochloride moieties, hydrochloric acid moieties, and forming the benzoic acid. Another example is hydrolysis of phenyl benzoate. Phenyl benzoate is the ester of benzoic acid. So this ester, when it is being treated with water, gives us like the esterification reaction. You might be doing that when you are heating an ester, it will be forming acid as well as an alcohol. Okay, so this phenyl benzoate on hydrolysis give us a carboxylic acid, that is our benzoic acid, along with phenol. Coming to the reactions of aromatic acids, okay, or the various aromatic derivatives and important aromatic derivatives which we will be having. So that includes benzoyl chloride, in which the benzoyl moiety will be having benzoic acid. When it is having this chloride onto it, we call it as benzoyl chloride. Okay, so benzoic acid, and it will be having the chloride. So it will be having C. So it will be having COOCl. Okay, so benzene will be having COOCl onto it. So that carbonyl moiety, carboxylic moiety of COOH will get the proton being get replaced by the Cl. So benzene, when it is having that COOCl, we call it as benzoyl chloride. So this will be attached to the benzene ring. So similarly, benzamide, when it is having NH2 instead of that chloride, we call it as benzamide. So likewise, we'll be having various derivatives of benzyl chloride, benzoic acid, that includes benzamide and benzoyl chloride, benzoic anhydride, benzoyl peroxide when there is a peroxide moiety, and we have benzonitrile, tolic acid. Okay, so toluene is having carboxylic acid, we call it as tolic acid. Antranilic acid, we have seen when it is having NH2 on the benzoic acid, we call it as antranilic acid. And salicylic acid, when it is having hydroxyl group next to it on the benzoic acid, that is salicylic acid. Likewise, benzene dicarboxylic acid, when it is having two dicarboxylic moiety onto it, and phthalic acid, benzene dicarboxylic acid, or even phthalic acid. Phthalic acid, when both the carboxylic acid are next to each other, when there is a gap, we call it as benzene dicarboxylic acid. And phthalic anhydride, when there is anhydride body instead of COH, when there is anhydride COO, CH3 attached to the benzene ring, that is phthalic anhydride. So these are few important benzoic acid derivatives, like phenyl acetic acid is also one of the example here. So these are the various derivatives of benzoic acid, which are having a very much important functional in the medicines as well as in the various manufacturing purposes. Going to the reactions, how these benzoic acid are going to react and what are the various important reactions. As we know that it is an acid, so we have a basic neutralization reaction. Acid, whenever reacts with the base, it forms a salt. So being an acid, benzoic acid also go towards this basic method of neutralization. It will be whenever it is going to react with the base, it will be giving the salt. Likewise, esterification. Esterification is also when carboxylic acid reacts with alcohols, they form ester. So the ester formation, as it is an carboxylic acid, acyl halide formation. So benzoic acid, when it takes up a halogen onto that proton, replacing the proton, we call it as acyl halide. Reduction of benzyl alcohol. So when it is losing out in oxygen, okay, and forming OH, okay, so carbonyl oxygen will get removed and forming CH2OH, we call it as benzyl alcohol. So reduction, reducing itself into benzyl alcohol. Decarboxylation, that breaking of that carbonyl moiety is called as decarboxylation. So these are the various important reactions what this benzoic acid undergoes. And another last one is electrophilic substitution. It doesn't undergoes faster rate, but it does have this electrophilic substitution, where the substitution occurs at meta position when the benzoic acid is there. So first is salt formation. So benzoic acid, being an acid, when it reacts with the base, forms salt. Okay, so benzoic acid, whenever it's going to react with base, we are taking example of sodium hydroxide. So it will be giving it salt, that is sodium benzoate. Similarly, benzoic acid undergoes esterification reaction with ethanol and concentrated sulfuric acid to form ethyl benzoate. Okay, so here ethyl benzoate is going to form benzoic acid. When it is going to react with ethanol, it is going to form ethyl benzoate, that is the ester. So here is what happening. It is a reaction between an acid and alcohol. Ethanol is alcohol. So in the presence of sulfuric acid, acid when reacts with alcohol, it gives ester. So that is a characteristic identification reaction of carboxylic acid. So this carboxylic acid's a strong pungent smell gets converted into sweet smell of ester when they are going to react with an alcohol. So that is esterification reaction occurs here. So how it occurs? The alcoholic moiety, the methyl, will be attacking onto the carbonyl carbon to form that ester bond to give us the benzoic acid ester. Next is acyl. Okay, so benzoic acid when treated with phosphorus pentachloride. So here what is happening? Acylation is occurring. So the benzoic acid moiety, when it is being reacted with phosphorus pentachloride, it will be forming the benzoyl chloride. So along with the phosphonyl chloride, this HCl. So benzoic acid, next is reduction, where benzoic acid gets reduced into benzyl alcohol. So here reduction is nothing but addition of hydrogen and removal of oxygen. So from the benzoic acid, one oxygen gets removed, two hydrogens get added up. So it happens in presence of a very strong reducing agent, that is lithium aluminium hydride. So this lithium aluminium hydride, when it is being reacted with benzoic acid, it reduces benzoic acid into benzyl alcohol. When benzoic acid, when it's being treated with soda lime, what is soda lime? Mixture of calcium oxide and sodium hydroxide is called as soda lime. Okay, so collectively, the mixture of calcium hydroxide along with NaOH is regarded as soda lime. It undergoes decarboxylation. Means the carbonyl moiety gets broken down and it will be giving us the benzoic acid gets converted into simple benzene. So whole COH moiety gets removed in the form of calcium carbonate. Okay, so CaCO3 it will be forming. This is from base and lime mixture, which is called as soda lime. It will be removing the carbonyl moiety and giving us the benzene. Next, electrophilic substitution. Usually it happens to be occurring with electron withdrawing group. Nitration is an example where benzoic acid can easily undergo, and it is the nitro group on the meta position. So the benzoic acid, when treated with nitric mixture or nitration mixture, which is mixture of nitric acid and sulfuric acid, to give meta nitro benzoic acid. So benzoic acid here, when it is going to react with nitration mixture, it is giving us the meta nitro benzoic acid because it is directing towards the meta position. So here if we go towards the first one is electrophile, nitro electrophile forms. This nitro electrophile have only these available positions because of the presence of carbonyl moiety. It gives the positive charges on both the ortho and para positions, due to which our electrophile won't attack on that. So this position as well as this and this, these three are being backed up or being occupied by the positive ions, so due to which the nitro won't attack there. So the available position for the nitro is meta, so it will be attacking on the meta position. Formation of aluminum ion is happening here, and this aluminum ion will undergo deprotonation to give us the nitro substituted benzoic acid, that is 3-nitro benzoic acid. Next is halogenation. Another reaction is halogenation reactions here, where halogen is going to get attached onto the benzoic acid here. So benzoic acid, when it is being treated with the halogens such as bromide and all, it will be giving again halogenation also occurs at the meta position. Any electrophilic substitution will be occurring if there is a benzoic acid on the meta position because it is a meta director and deactivating group. So here, first is a formation of bromide electrophile. This bromide electrophile, again, it will be having the ortho and para position occupied by the positive charge during the attack. So that is why it will be having only meta left. So that is why the meta bromo benzoic acid is getting formed. Sulfonation also occurs on the third position. So 3-sulfur benzoic acid will be able to get. Similar way, sulfonation also being going to be forming the same aluminum ion that will be attacking the meta position, and which on deprotonation give us 3-sulfur benzoic acid. So what are the various important uses of this benzoic acid? Like simply, we know that benzoic acid derivatives have many uses. Apart from its derivative, even simply benzoic acid is also used as a germicide for killing or for the treatment of urinary tract infection, for removing or killing the germs from the urinary tract, as well as is an important food preservative. You might be seeing in various shopping malls and all, that you will be having some packs arranged on that. The foods will be having this benzoic acid attached. So due to which what happens, its shelf life gets increases and it won't get oxidized easily. So that is why benzoic acid will be used as a food preservative. So this benzoic acid, aromatic acid, is a part of second unit of POC2, pharmaceutical organic chemistry 2, of the 2-1 or the third semester to be precise. And in that, apart from this aromatic acids, we are having other important concepts that includes acidity of phenols, effect of different substitution on acidity, basicity of aromatic amines, effect of substitution on the basicity. These are also important topics. Apart from the carboxylic acids, mechanism of aryl diazonium compounds, because these are also included in the second unit, aryl diazonium compounds, then synthesis of aromatic acids and its chemical reaction. So these topics you need to be covering while you will be studying, because they might be asking you about what are the various substitution reactions of phenols or mechanism for the substitution reaction of phenols, acidity of phenols, basicity of amines. Very, very important. Both the questions are equally important. Acidity of phenols as well as basicity of amines, and effect of substituent on the basicity, like amines basic nature, will how it get increases, how it get decreases, okay, due to which group, like electron withdrawing or electron donating, how the basicity gets changed or modified, we'll get to know. Next is mechanism of aryl diazonium compounds. Aryl diazonium compounds are very, very important precursors for many compounds, because some reactions are like very difficult to directly complete through benzene or its derivatives. So what we do, first we will be converting benzene to aryl diazonium compound, and from that aryl diazonium compound, most of the reactions which are not easily practically possible with direct benzene can easily be done through using aryl diazonium compound. So that is why aryl diazonium compounds are very important reagents or derivatives of benzene, which helps for synthesis of many compounds, which include benzoic acid, benzoyl chloride, toluene, nitrobenzene. So this aryl diazonium compounds plays a very important role for synthesis of multiple different benzene derivatives. Next is synthesis of aromatic acid and its chemical reaction. So what we have discussed today, those are also an important concept. So that can also be asked either for 5 marks or even for the 3 marks in very short concepts, where they will be asking you about trying the various method of preparation of aromatic acids, or they might be asking you about reaction of various aromatic acids. And next is acidity of aromatic acid. So we have seen that effect of substitution on acidity. We have seen electron donating group are decreasing the activity, as well as electron withdrawing group increases the activity. So that you need to be explaining or mentioning with a few examples, like with the structural representation, show that how this acidity electron withdrawing group or electron donating group decreases, and In that you can also include the orientation part also, where aromatic acid will be directing the further electrophilic substitution towards the meta position. Okay. So coming to the multiple choice questions that there based on our discussion, like all the questions are not having like it's not like out of portion time, because whatever we have discussed in the webinar that will be there in this MCQ. Okay, so here, like, what is aromatic acid? Like a compound of hydroxyl group, compound with one or more carboxyl group attached direct to aromatic ring, or compound with amino group attached to an aromatic ring, or compound with halogen group attached to an aromatic ring. What is an aromatic acid? Likewise, another question. According to Lawry-Bronsted theory, why benzoic acid is considered an acid? It is very simple answer. Might be like you might be knowing. I'm not going to disclose the answer here. You should be answering it. Okay. So it donates electron. It donates proton. It accepts proton, or it accepts electron. So why it is Lawry-Bronsted acid? Next, which group increases the acidity of benzoic acid? This one I discussed: electron donating, trophilic, electron withdrawing, or none of the above. What is your answer for that? Next, why does carboxyl group in benzoic acid direct electrophile towards meta position? What is the reason behind? Meta position is more electronegative, repels electrophiles at ortho and para. Electrophile are attached to ortho para position. Meta position have the lowest electron density. Next, which of the following is not a preparation method for aromatic acids? Oxidation of benzyl, reaction of phenyl magnesium bromide with carbon dioxide, reduction of benzoic acid, hydrolysis of benzonitrile. Okay, so these are the various which among them is not the method of preparation. Okay, so you should need to predict the correct one. What is the form when benzoic reacts with phenol in presence of concentrated sulfuric acid? Benzoyl chloride, ethyl benzoate, benzyl alcohol, or sodium benzoate? Which reagent is used for formation of acyl halide from benzoic acid? Phosphorus pentachloride, sodium hydroxide, sulfuric acid, or nitric acid? What happens to benzoic acid during decarboxylation? It forms benzene, forms benzyl alcohol, it forms benzoic anhydride, or it forms benzoyl chloride. So what happens? What is the product of benzoic acid decarboxylation? Which of the following is derivative of aromatic acid? Which is it? Benzoyl chloride is derivative, benzene, benzophenone, benzyl chloride. Okay, among that, what is the derivative of benzyl aromatic acid? What is the use of benzoic derivatives in healthcare? Just now we have discussed, you might be doing well. Treatment of diabetes, germicide for urinary tract infections, pain relief, anticoagulant. Okay, so these are the various multiple choice questions based on our webinar, which we have discussed regarding the benzoic acid, where we have seen what are the various, what are these benzoic acid, which compounds are called as aromatic acids. Simply benzene derivatives with carboxylic acid are aromatic acids. So what are there? What are the important examples are there for them? Then how they are prepared, and what are the various chemical reactions that usually they undergo? Or what are the important derivatives of these benzoic acids are, and what are the uses these benzoic acids will be having? So these are the various things which we have discussed today in our webinar. Likewise, for much more discussion regarding in detail about pharmaceutical organic chemistry. You can go through the Prakara app where you will be having much detail about each and every topic from whole the pharmacy syllabus and from organic chemistry as well as all the other subjects where you can be getting full detailed videos of all the subject related material along with the video. So follow this app, follow this, subscribe to the channel so that you would be getting free webinars about the various topics which will be specified through the WhatsApp groups, where we will be discussing about specific topics related to each subjects. And then in detail, you will be getting full-fledged informations and detailed classes in the Prakara app, where you will be having all the pharmacy, pharmacy related all information for each subject, where the faculty will be discussing in detail the subjects along with the full explanations. Thank you all for joining me for this webinar and having a session regarding the aromatic acids from pharmaceutical organic chemistry.